So I'm going to demonstrate two very closely related ways of graphing a cosine or sine function that has a given amplitude, phase shift, and vertical shift. So for example, let's focus on this one example, y equals 4 minus 3 times the cosine of 2x plus 3 pi over 4. Okay, I've made this moderately complicated for the purpose of being sure to cover as many bases as I can, and I think it represents, sort of the function, the type of function you're expected to be able to graph. I'm going to do most of this as a sketch because this is really conceptual, and I want to be sure that you understand the concepts. I'm not so worried that the graph looks pretty. Okay, so let me draw y-axis and an x-axis. And let's start at the beginning of what we're supposed to do first, or at least in the way that I like to do it. I like to sketch out a channel. So I like to be able to sketch what the baseline of the function is going to be. That is, what is the line that it's going to oscillate around? What is the line that represents the maximum value that the function will achieve, and what is the line that represents the minimum value that the function will achieve. So I sort of have drawn a channel where the function oscillates up and down between the channel. So by looking at this, I could see that my vertical shift is a positive 4. So let me just sort of 3, 4, 5, 6, 7, 8, 9, 10. Let me just sort of sketch in a couple of y ticks. And so I've got a new baseline that's, instead of being oscillating around the x-axis, this graph is going to oscillate around the line y equals 4. So 1, 2, 3, 4 is going to be the new baseline for the graph. And its amplitude is 3, which means it's going to go down 1, 2, 3. It's going to be its minimum value that it will achieve. And it will go up 3 from the baseline, 1, 2, 3, and that is going to be the maximum value. Okay, so regardless of which method you use, I like to first sketch out a channel so I know where to draw my curve between. It's going to be going up and down, somehow hitting this curve at a maximum value, this line at a maximum value, this dotted line, and then it's going to go down to that dotted line. Okay, so that's sort of first. And now I sort of separate these methods into two. One of them I call scale and slide. And the other I call slide and scale. Okay, they're both very closely related, and there's only one minor difference between them. The way that you've learned in the book, and I think on the videos that you've seen so far, is the scale and slide method. So let's take out the 4 and the 3 from this. Okay, I don't want to be dealing with the amplitude. I can do that at the very last minute by just fitting it to the channel. So I'm not going to worry about the amplitude. I'm not going to worry about the vertical shift, but I do need to keep the negative sign here. So for the scale and slide method, I'm going to focus on minus cosine 2x plus 3 pi over 4. Okay, and I'm going to be needing to do the factoring to factor out the coefficient of x to get this function 2 times x plus 3 pi over 8. Okay, so that when I distribute, I'm back at 2x plus 6 pi over 8 or 3 pi over 4. So I haven't changed the function, I've merely just factored out a 2. In the scale and slide method, this is the scale factor, and this is the slide factor. Okay, so I start by looking at my parent function, which in this case is negative cosine x. Okay, and I'm going to go ahead, and I need to know really well how to plot negative cosine x. So I need to know that it looks like this. Okay, and we've got 0 here, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and the first thing I'm going to do is scale. Scale is relatively easy. I'm simply going to divide each one of these values by the scale, which is 2. So let's go ahead and divide everything by 2. I'm going to keep the same curve, but I'm going to have 0. Instead of pi over 2, I'm going to have pi over 4. Instead of pi, I'm going to have pi over 2. I'm going to have over here 3 pi over 4, and here I'm just going to have pi. So these landmark points, the minimum, 0, maximum, 0, back to minimum again, are 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then the second thing I'm going to do in this method is I go ahead and I slide. Okay, and I'm going to slide, and I'm going to use the factor of positive 3/8, which means I'm going to be sliding to the left. Remember, positive means going to the left by 3/8. So all that really means is I'm going to subtract 3/8 from every one of these numbers. So let me go ahead and basically 0 minus 3/8 is negative 3/8, is negative 3 pi over 8. 0 minus 3 pi over 8 is negative 3 pi over 8. Pi over 4 minus 3 pi over 8 is negative pi over 8. Pi over 2 minus negative 3/8 pi is going to give me just pi over 8. 3 pi over 4 minus 3 pi over 8 is 3 pi over 8. And pi minus 3 pi over 8 is 5 pi over 8. Okay, and these are still going to be the points that fit this curve. So we're still going to have our minimum value here. We're going to hit 0 at negative pi over 8. We're going to hit our maximum point at pi over 8. We're going to come back down to 0 at 3 pi over 8. And we're going to come back down to our minimum value at 5 pi over 8. Okay, and basically we're done. My handwriting and artistic ability cannot come anywhere near that of Ms. Walker. But I think what you can see from this is that we actually have points that we can now map onto an XY plane. So let's go ahead and let me imagine that I've got this graph broken up into eighths. 1, 2, 3, 4, 5, 6, 7, 8. Let that be pi. And then 1, 2, 3, 4, 5, 6, 7, 8 on the left side. Let that be pi. So now I'm going to take this curve here, and I'm going to simply note that negative 3 pi over 8 is my minimum. So I'm going to go 1, 2, 3. This becomes my minimum value there. Negative pi over 8 is 0. So I'm going to go ahead and where it's negative 1 pi over 8, I'm going to put 0. And you can refer back and forth. I won't keep moving the paper. Pi over 8 is the maximum. 3 pi over 8 becomes 0. 5 pi over 8 becomes the minimum. And you can see the pattern is that as we move to the right, every 2 pi, we're shifting from maximum to 0 to minimum back to 0 again, and then to maximum, which would be somewhere over here to the right of pi. And the same thing is happening to the left side as well. So we are at 0 there, and we're at maximum there, and then we're back at 0 over here. So what we can do is we can join the dots and get ourselves our curve. Okay, so we have now sketched, using the scale and slide method, we have now sketched the correct graph. So let me just kind of zoom out, give you a chance to see all the calculations that are done in this method So you see from start to finish what it requires.